Let's find the revenue function and marginal revenue function using the price demand function, that is P equals 225 minus 0.25x, where x represents the iron ore in tons. So let's find the revenue function. This is given by R of x, and it's given by the formula x times of P, or P of x. This one is basically the function P of x. So let's substitute the P of x here. So it becomes x times of 225 minus 0.25x. And so distributing the x, we get 225x minus 0.25 x times x is x squared. So this is the revenue function R of x. Now let's determine the marginal revenue function. And this is given by the derivative of the revenue function r prime of x. So we find the derivative of the right side expression. The derivative of 225x is 225, and the derivative of x is 1, so it is 225 times 1 minus 0.25. The derivative of x squared is 2x, using the power rule of derivatives. So let's simplify this. We get r prime of x. This equals 225 minus 0.25 times 2x is 0.5x. And so this is the marginal revenue function. We now determine the production level at which the revenue is maximum. For that, we find this equation, that is r prime of x equals 0. We set up this equation and determine the x. We have already determined r prime of x, which is the marginal revenue function. So let's set this up equal to 0. So therefore, 225 minus 0.5x, and this equals 0. And we can add 0.5x on both sides. So we get 225 equals 0.5x. Dividing both sides by zero point 0.5 and solving for x, we get 225 divided by zero point 0.5. And so this equals 2250 divided by 5. So this equals 450. So this is the production level at which the revenue is maximum. We can verify that by doing the second derivative of the revenue function. So let's find the second derivative using this r prime of x. So we get r double prime of x, and this equals the derivative of 225 is 0, minus the derivative of 0.5x is negative zero point 0.5, and so this is negative zero point 0.5. So according to the second derivative test, when the second derivative is negative, this one is always negative. Whether we plug in this x equal to 450, basically this x is the critical point of the revenue function. So whether we plug in or not, since it is independent of x, it's always going to be negative. So according to the second derivative, this is a point of maximum when the second derivative is negative. It's a point of maximum. So therefore, at this production level, that is at x equal to 450, uh, the revenue is maximum. So we see that at x equals 450 tons of ore, the revenue is maximum.